Good morning, students. In today's class, I will explain some few lab programs which are designed based on the concept that you have learned so far. In today's class, I will be explaining three different programs. The first one is to convert the temperature from Fahrenheit to Celsius and vice versa. The second one is to find the factorial of a given number. And the last one is to generate all prime numbers between m and n using functions. Let us start with the first program, that is to convert the temperature from Fahrenheit to Celsius and vice versa. Vice versa means in the second case, given Celsius, you have to convert its equivalent Fahrenheit. So the formula to convert from Fahrenheit to Celsius is C equal to 5 by 9 into F minus 32, where F is the temperature in Fahrenheit and C is the equivalent temperature in degrees Celsius. The second case, to convert from Celsius to Fahrenheit, the formula is F equal to 9 by 5 into C plus 32. So the first two lines are the header file, hash include iostream.h and hash include conio.h. From the iostream.h, we are using the library, you are using cin, cout, insertion operator and extraction operator. From the conio.h, we are using two library function, clear screen and getch. So void main float f comma c. In the first part, f is the input, c is the output. The second case, c is the input and f is the output. For the first part, you have to convert from Fahrenheit to Celsius. So you have to give the temperature in Fahrenheit, enter the temperature in Fahrenheit, C in F, input the value for F, then equivalently convert it using the above formula, C equal to 5 by 9 into F minus 32. Next, equivalently, you display the output. CO temperature in Fahrenheit, you display the value of F. Next line, display the temperature in Celsius, display the value for C end line. So the first part is to convert from Fahrenheit to Celsius. The second part is also more or less very simple, similar to conversion from Fahrenheit to Celsius. Enter the temperature in Celsius. So here you have to input the value for C. Equivalently, you get the value for F equal to 9 by 0, 9.0 divided by 5.0 into C plus 32. So here the input is C and the output is F. So Cout temperature in Celsius, display the value of C. The next line, display Cout enter the temperature in Fahrenheit, you display the value of F, get CH and close the bracket. So as an example, input output, how to give the input. If you run that program, first the system display the message, enter the temperature in Fahrenheit, you give some value. As an example, I have given 37 and temperature in Fahrenheit is 37 and temperature in Celsius will be 2.78. For the second part, you have to input the values in Celsius, enter the temperature in Celsius. I have given one example 13 and equivalent temperature in Celsius. So now the output is temperature in Celsius is 13 and the temperature in Fahrenheit is 55.4. Since you have declared C, F, everything as float type, probably in the output, it will display at 37.00006 times 60. Similarly, second case, 2.78000 like that. So in case of float variable, you will have 6 digits of precisions. The second program is to convert the fact given to estimate or to determine the factorial of a given number. So this program already studied in your C language, also in data structure part. So here the input is the n and equivalent output, that is factorial of n, you store it in R. So the first two lines just similar to previous program. Next, int n. So given number is in integer type. Output, the factorial of an integer number need not be always integer. Up to 7, it will be input is also integer, output is also integer. But 8 onward, input is only integer, its output will be long integer type. So the prototype of the function is long int fact. Inside the bracket, I mentioned int mean the function name is fact. It takes only one argument of int type and the return type is long integer, and the equivalent variable to store the result I have declared CR. Clear the screen. Enter a number, input the value for n, C in n. Then you call the function R equal to fact of n. So the fact is a called function which takes the value of n as input. After computing the factorial of n, it returns some number that is received by R. So R is the factorial of the number. So see out factorial of whatever number you have given. Suppose n equal to 5 means the output will be factorial of 5 equal to 120. So here I have to write a function called fact. Return type is long int. Function name is fact int n. So to start with, a long int r equal to 1, because in order to compute the factorial of a given number, you initialize the value of r equals to 1. For example, if you are computing the factorial of 4, so n value will be 4. So your for loop for int I equals to 1, I less than or equal to n, I plus plus, it varies 4 times. First time I equal to 1. So r is initially it is 1. 1 into 1, it becomes 1 only. Next becomes I becomes 2. So r is already 1. 1 into 2, it becomes 2. Now the current value r is 2. Next time I becomes 3. 2 into 3. So r value will be 6. Next I becomes 4. 6 into 4, it becomes 24. So your for loop is executed 4 times. After that, you return the value of r. So r value will be 24. So you should note one difference between the way for loop is used in C and C++. In case of C, the value of I also must be declared as int I. But in C++, one flexibility is there. Inside the for loop only, you can declare and initialize the value for I. For int I equal to 1 means it declares a variable called I of integer type and initializes it with a value equal to 1. So that is a flexibility of C++. Whereas in C language, you have to first declare int I, then in the for loop, you have to write it as for I equals to 1. Trial 1. So I have executed the program with 2 different inputs. Enter a number. I have given 5. Factorial of 5 is 120. The second time you execute the program, you give some other number. Here I have given the number as equal to 8. Factorial of 8 will be 4320. So 4320 is not an integer number. It's a long integer number. The last one is to print all the prime number between m to n using function. So you have to display all the prime number between 2 limits. If m equal to 10 and n equal to 20 means your output should be 10 is not a prime, 11, 13, 17 and 19. 4 numbers should be displayed. But you have to check whether a given number is prime or not using function. You write the function only one, but you have to call it many times from for loop, which varies from the value of m to n. So int m comma n comma I. M and n are the 2 limit, between which 2 limit you have to calculate, you have to display the prime number. And you have, in order to, since you are using a for loop, we are taking a control variable called I. Int prime int. So in this program, the main function is calling a function called prime that takes one number as an input and returns integer type. So if the given number is prime, it returns 1. The given number is not prime, it returns 0. So anyway, the output of the prime function is either 0 or 1. 0 or 1 is definitely an integer number. So the return type is int prime and input is also integer. So if we give 13, in that case, 13 is not a prime number. So 13 is a prime number. In that case, the function prime returns 1. Instead of 13, if we give 15, then the input is 15, the output is 0 because 15 is not a prime number. Enter the limits C in m and n. You have to input the value for m and n. If you assume that, suppose for m you have given 10 and n you have given 20 means then prime number between 10 and 20. See, you have to vary the for loop which varies from the value of m to the value of n. So I loop varies from 10 to 20 provided m value is 10 and n value is 10. First time I is equal to the value of m. M is 10 means first time I becomes, so your for loop varies from 10 to 20 means first time I equal to 10, next time it becomes 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So 10 times the loop is varied. R equal to prime of I. First time I value is how much? 10. So it go to the function called prime function and first number is 10 means 10 is not a prime number. So in that case, the function prime returns the value of 0. So only when the function returns 1 means that's a prime number. If 0 is returned means the given number is not a prime number. For example, if your m value is 10 and n value is 20 means first time for the prime function you are passing 10, in that case r value will become 0. Next time I value becomes 11. In that case, R value is 1. Next time, 12 means R value is 0. 13, R value is 1. 14, R value is 0. 15, R value is 0. 16, 0. 17, it is 1. 18, again 0. 19, it's 1. And 20, 0. So, whichever number is prime, in the correspondingly, the R value will be 1. For all the non-prime number, for composite number, R receives the value equal to 0. So you have to display the value of I only when R equal to 1. That means it's a prime number. Next, if R equals to 1, you display the value of I. So for 10, 11, sorry, 10, 12, 14, 15, 16, then 18, R value is 0. So don't display that number. Only for 11, 13, 17, 19, R value is 1. So only when I take these 4 values, you display the corresponding value of I. Next, below this one, I've written the function called prime int x. So that function prime takes any number called x. If the given number is x is a prime number, it returns 1. Otherwise, it returns 0. So int, you declare an extra variable called r. Initially, you keep the value of r equals to 1. Next, in order to check whether any number is prime or not, you start dividing from 2 up to half of that number. For example, first time, R equal to prime of I. So if your suppose the m value is 10 and n value is 20, mean I value will be first time it is 10. So now the value of I is passed on to x. So x also is now 10. Next, initially R equal to 1. So your J loop varies from 2 to x value is 10. So 10 by 2, 5. So first time you divide 10 by, you divide x by the value of j. J is 2. 10 percentage 2 equal to 0. It automatically returns 0. So R value becomes now 0. So in that case, the value of, since R value is 0, so it will not display the value of I. Next time, I becomes 11. So the function call will be R equal to prime of 11. Now go to the function int prime int x. So now x value will be 11. Here also for loop, J loop varies from 2 to 11 by 2. 11 by 2 is also 5. So first time x is 11. 11 when divided by 2, remainder is not 0. 11 when you divide it by 3 also, remainder is not 0. 11 by 3 also not 0. 11 by 4 also not 0. And 11 by 5 also not 0. So your for loop is over. After coming out of the for loop, you return the value of R. Initially, you have mentioned R equal to 1 means, return the value of R means 1 is written. So here what happens is R value equal to 1. If R equals to 1 means, you display the value of I. So 11 is displayed. So like that, each time it receives the value, it takes the value of I. That value is received by the variable called x. Then if the given number is prime, it returns 1. Otherwise, it not return 1, it returns 0. So only you display the value of I when R receives the value 1. When R receives the value 1 means the given number is prime number. So as an exercise, you can solve this problem in your free time. Write a C++ program to reverse a given number, find the sum of digits in the number, to find the sum of n natural number, but try to write the program for these using functions. Probably in your previous exercise, I have given this exercise without writing function. Now try to write the program for these things using functions. Write a C++ program to find the sum of n natural numbers, whether given number is prime or not, just now has shown. Write a C++ program to print Pythagoras triplet from 1 to 100. So all are very simple program, but all the 3 programs that I have explained today will be your practical lab programs. So try to start writing them in your practical record book. In the next class, I will tell you what is the order in which you should write the programs in your practical record. So my sincere advice is to execute all the 3 programs using C compiler that you have loaded in your laptop, or if probably you try to find a compiler which is suitable for mobile also. Nowadays, some C compilers are available for mobile application also. You download them and try to execute it. And if you already have a laptop with you, so straight away can start executing all the 3 programs. Last 3 programs that are given as an exercise, you try to make an attempt. But 3 programs, what I have taught today, will be your practical program. For any of your doubts, clarification, you can contact with any of those 3, any number or the email ID or the You can post your comment in the comment section of Google Class. With this, I'm going to conclude today's class. In the next class, I will explain some more practical program, because all the program that I have written today is based on the concept that you have already learned. Already you have learned function, you have learned using control structure, etc. In my next class, I will be explaining some program based on the different concept like function overloading, default argument, and inline function. Thank you.